Alright, so what we're gonna do, do you all have the handouts? So we're gonna start with talking about the physical characteristics of soils. Now there are certain chapter objectives. You can see at the top of each chapter I have clear objectives for this particular chapter. So at the end of this particular chapter you should be able to define the specific gravity of the soils, what it means. You should be able to calculate and plot grain size distribution of soils. You should be able to classify soils based on the size and know what hydrometer means. I always ask this question, what is hydrometer, in one of the exams. Hydro, water permeability, and I always ask, put a trick question, say hydrometer is a permeability device, which is not. Okay? So I'm telling you right now, you'll learn about what it is. So what we do is, before we design any structure, we always either get a sample from the field and we look at the structure. Let's say what you're seeing here is you have a whole bunch of different layers. They have different colors. Now what we need to do is we need to be able to classify the soils based on certain things. Let's talk about them. First thing I'd like to talk about is the physical characteristics of the soils. What are the physical characteristics? The first one is going to be specific gravity. G sub S, specific gravity. The second one, grain size distribution. The third one, unit weight, in parentheses S, unit weights. As I mentioned, there are 4 of them. We're going to talk about gamma, gamma sub D, gamma sub S, and gamma sub sat. So we have 4 unit weights we're going to talk about. The equations are slightly different. For something what we call liquid limit and plastic limit. Liquid limit, plastics limit. We're going to talk about all that. Alright, you're passing the samples. So now let's talk about the specific gravity of the soils. The definition of specific gravity, I'm sure you heard before. It's essentially density of soil or unit weight of soil to the ratio of density or unit weight of soil to the unit weight or density of water. So it's a ratio or unit weight. This is how we define specific gravity. So those of you who have seen, who have taken 337, of course you know what specific gravity is. For asphalt, for example, you have a whole bunch of specific gravities, right? So for aggregates, you have you have GSE, GSB, and GSA, apparent specific gravity, right? These are all different definitions of specific gravity. Now let's talk about geotechnical engineering and soils. In soils, we have a single specific gravity that we define, which is shown in here. Density of the solids, rho sub S, divided by the density of water, which is the same thing as unit weight of solids. Sub S is for solids, not soil. Solids. If you look at this, the unit weight of there's a here typo here. This is going to be solids. Solids of the soil, solid part of the soil. So W sub S is the weight of the solids. and V sub S is the volume of the solids. I'm making a distinction between the solids and the soil. I'm making a distinction between the solids and the soil. You will see in the next chapter so let's say we have a unit volume. Let's say we have a unit volume of soil. This is called soil. You have a whole bunch of grains, and in between grains there's some water too, because they are moist. Let's say this black area in between the grains, there's some water. Okay? So the soil is composed of solids plus water plus air. We're going to talk about that. You know about phase diagram, so I'm not going to spend too much time here, but the soil is composed of solids, water, and air. So if you remember from 337, if you have taken it, there were many things. There is the asphalt, there is the absorbed asphalt, there is the aggregates, there is the air, there's a whole bunch of things. But in soil mechanics, in geotechnical engineering, when we say soil, we mean solids, solid particles. These are the solid particles, water, and the air. So there are three phases. Phase diagram includes three portions: solids, water, and air. So this is the solid portion, the weight of the solids divided by volume of the solids. That does not include the water, it doesn't include the air either. So this is a definition. Alright, so I'm going to pause for a second.